It's Barry Johnson from SolarTwin on why PV pumped solar water heating is so amazing and how it's going to storm the world. SolarTwin make a large solar heating panel with a 5-watt PV on it, and adding PV pumping makes the operation zero carbon instead of low carbon. So what, you may ask? Well, it makes a huge difference. Here's why we bother, and here's how we prove it's far greener. And we're going to give you numbers. All the data is third-party sourced. This is what SolarTwin is made of. There's a mini panel on the left there, a PV panel in the middle, a controller on the right, and a small pump lower down. We submitted these in full to Bath University, who were doing a comparative study of the environmental impacts of 3 kinds of microgeneration technologies: micro wind, solar PV, and solar hot water. And boy, was that a detailed process. Here's some examples of what they actually did. On the left, here's a diagram of the micro wind, the PV, and on the right, the solar thermal. And what if that pump was mains powered instead? Well, we've been able to now get together some field data from UK to work out what the energy and environmental impacts would be if there was a mains powered pump instead of a PV powered pump on the SolarTwin installation that was there. And the answer is, energy payback takes 1 year longer with mains pumping. Carbon payback takes 3 years longer, and the lifetime CO2 emissions are about 3 times worse. Really shocking, eh? There was a complex energy payback analysis done. Here are the results. Micro wind, the numbers aren't too sure because there's a huge variation in wind supply. For solar hot water, PV pumped, the energy payback was 1.5 years. And using data from the Energy Saving Trust, we calculated that it was 2.5 years for the same solar heating system if it used a mains-powered pump with a mere 55 kilowatt hours of energy per year. Now that's a lot less than some data suggest. The carbon payback, if it's PV pumped, is 1.2 years. In other words, in less than 1.5 years with a PV pumped solar heating system, you're into carbon break-even. But if you add a mains pump, it's 4.2 years. 3 years longer. The question for solar thermal users is, do you want your chosen solar thermal installation to have avoidably long energy and carbon payback? I'm sure you don't. The other way to turn the question round is to say, how many times do you save your invested energy? And to summarise the data, your invested energy is paid back 17 times with PV pumped solar hot water, but only 10 times if it's mains pumped. But look at the figures for CO2. In your lifetime, the CO2 is saved 21 times with solar hot water if it's PV pumped, but only 6 times if it's mains pumped. What's interesting is the Advertising Standards Authority in UK hauled us over the coals recently for saying that our solar heating system was zero carbon. Well, frankly, I still think it's better than zero carbon. What do you think? We ended up graffitiing over our website because we really didn't think it was a disgrace to be hauled over the coals. Do you want your chosen solar thermal installation to pay back its lifetime carbon emissions 21 times or just 6 times? Mains pumping or PV pumping? It's your choice. The data we used was from a big complex table, which was a summary of further data from the Bath University study. Thank you to everybody there for their help. We then did some calculations which showed, yet again, that adding mains pumping tripled your CO2 emissions. Tripled them. Shocking, eh? Well, SolarTwin have been doing PV pumping for years. We've a solar controller. The point is that if you're trying to eco-build, you're trying to do anything sensible, does it support PV pumped solar thermal? And the answer is yes. Carbon is the new currency. If you want to be carbon efficient, you've got to move away from component efficiency in solar thermal and move towards system efficiency and sustainability. And if you're trying to deliver a zero carbon home, it's going to be very hard to do with mains pumped solar thermal because it's pouring out CO2 at the power station chimney. So what sort of carbon clawback does a solar heating system have? Well, it can have about 13% in terms of negating what you save in terms of your gas saved in a house by emitting CO2 at the power station chimney. It can be 13% or it can be 0. I'm going to show you some data on this in a moment, but if you just want to have a look at the arguments against PV pumped solar heating, here they are. But of course there are some in favour as well. I'm not going to go through them in detail. The big thing is, of course, that there's a payback challenge for solar. And you can do it with money, or you can do it with another currency. Conventional solar starts expensive, takes a while to break even. With new solar, not necessarily SolarTwin, because we haven't reached our destination yet, the aim for it to start less expensive, recover more quickly, break even sooner, pay back faster, and last longer. And you can substitute carbon dioxide for this budget equation as well. And that's what we've been talking about earlier. The secret is to cut your costs, minimize your running costs, hasten your payback, maximize your life expectancy, and eliminate your carbon clawback by having PV-powered pumping. If you'd like to compare old with new solar heating, there are loads of different ways you can compare them. But if we look at the bottom three lines, if you look at energy payback time, what do you want? 2.5 years or 1.5? Carbon payback time, 1.2 years or 4.2? Or would you like to repay your emitted carbon dioxide 6 times in your product's life or 21 times? It's your choice, PV pumped solar or mains pumped. Because at SolarTwin we've inverted the design priorities. Conventional solar has efficiency per square metre at the top of the priority. It's some kind of strange fetish. And then maximising the total annual performance, and then at the bottom, environmental stuff. Well, we inverted those. We put the carbon and the environmental efficiency at the top and changed from maximising annual performance to optimising it, and put efficiency per square metre at the bottom because we're looking at system efficiency and a global environmental performance. So we really are focusing on carbon savings from the PV pumping and from other areas. So specify solar heating because it's greener. Field trial data, as well as the life cycle we've talked about, supports it as well. So here's the big picture. Do you want to see things black and white or shades of green? Here are the shades of green. The Energy Saving Trust in 2001 concluded that 8.3% of the energy of a solar heating system was negated by having mains pumping. But the point is that there's a very high carbon weighting of electricity, which means that you've got about a 21% carbon clawback. They then did some field trial 10 years later and found a 13% carbon clawback, which is better. It's an improvement. People are saying, you haven't got the evidence. This is why I'm looking at these studies. The Department of Trade and Industry did a study which also concluded there was between 17 and 23% carbon clawback in a typical gas home by running solar heating. That clawback happens at the power station chimney, and with PV pumping you can switch that off. Here are some different types of solar thermal configurations, and here are our best calculations of the expected, in the right hand side, the expected lifetime CO2 emissions, just due to pumps, not to manufacture but to pumps. And you can see that you can put over a tonne of CO2 into the atmosphere with a conventional solar heating system. Don't do it. There's no need. The DTI study on solar panels was really interesting as well because it showed, look at the bottom two grey figures in the red oval, that they had enormous carbon clawbacks. Those bottom two were evacuated tubes. Evacuated tubes need big pumps to work. If you really want to knacker the environment, buy evacuated tubes. And here's a summary of all the field trial data that I've been able to find that's UK based on carbon and energy parasitics. The most up-to-date is in the ring, 13% as a median for Energy Saving Trust for carbon clawback, and nothing for PV pumped. Well, the situation's improving. Energy parasitics have fallen in a decade from 94 kilowatt hours of electricity needed to pump a solar heating system to 55. That's nearly half. It's good. The carbon clawback's fallen back, but it's still the case that mains pumping can roughly triple a solar heating system's lifetime CO2 emissions. And you can reach carbon break-even 3 times later using mains pumping compared to PV pumping. And PV pumps cut carbon and energy clawback to 0. So if you want to eco-build, what do you want to do? Well, it's good to know about your environmental impacts, on energy and carbon dioxide, but also the other aspects of water and air pollution and so on. And choosing your eco-designs by assessing them and prioritising them quantitatively. If you don't get the numbers, you won't be able to make good environmental decisions. So you need lots of information based on life cycle analysis. And don't forget, look out for the greenwash. But one wonders, why are so few people offering PV pumping? Well, PV pumping does cost slightly more, but it costs less to run. Customers are being discouraged by government from taking up PV pumping in UK because the Enhanced Capital Allowance Scheme, which is a tax break scheme for business, promotes mainly evacuated tubes, which have got the worst parasitics, the worst environmental damage. The Renewable Heat Incentive, Phase 1, also discourages industry from using PV pumping because it rewards gross heat, not net heat. Absolutely bonkers. It should reward not the total heat that you get from a solar heating system, but the total heat minus the electricity that you use to pump it. We need a change here. And I suspect a domestic phase of this, phase 2, will do the same thing. And of course, there's industry resistance throughout regulation to cover this sort of thing up, because so many companies have got themselves locked into the old carbon parasitics way of operating. They shouldn't. Even the Microgeneration Certification Scheme, the UK regulator and gateway to subsidies, blocks proposals for life cycle analysis and blocks proposals for telling consumers how many years to carbon and energy break-even are needed for microgeneration. It's shocking. So what can the UK government do? Well, it needs to be pro-environment, pro-innovation in UK and abroad. It's got to fund only net energy benefits under the renewable heat incentive, because currently over £100 million, yes, £100 million is going to waste to pay for non-existent energy benefits. It needs to reform the enhanced capital allowances so zero carbon operation systems get tax breaks instead of being excluded from them currently in UK. And it needs to require microgeneration installers to quote the net thermal energy benefit, not the gross, because the net deducts the pump energy. And it also should require consumers to know, because suppliers should be required to tell them, the years to carbon and energy break-even for typical microgeneration installations. This is a secret that's being covered up. You need to ask for this as consumers. Ask for your published life cycle analysis of your microgeneration technology. And if people don't give you that information, you could be being sold a pump. So if that pump is mains powered, energy payback takes a year longer. Carbon 3 years longer, and the lifetime CO2 emissions worse. And the government and the industry are not telling you this because they're covering up on life cycle analysis in the renewables industry. It's shocking. So specify PV pumped solar heating because it's greener with all the benefits that I've mentioned before. Faster energy payback, faster carbon payback, and a lifetime carbon emission which is better in terms of the manufacture and the emissions from the pumps. Thanks. It's Barry Johnson from SolarTwin.